So let's recreate our New York Times article using only functions that we've defined in R and create some of our own S4 classes so that we can use an object-oriented programming paradigm to actually go through and make the accessing of those images a little bit more intuitive. So I'm going to open up this example 6. So this is example 06, scrubbing in R. And this is a Jupyter notebook, but I'm not going to be using RPy2. I've actually installed the R kernel. So if I were to go in here to kernels, R is one of the kernels that I can actually use inside of the environment that I have. So this is a notebook extension. You can install that such that we don't need to use the R magics in here. It actually knows that we're going to be using R throughout the notebook. And so all of the code that we write will literally just be R. We won't need to use the %% R magics that we're going to have. So the first thing that I'm going to load here are a couple of libraries. The first one is HTTP examples in R, so HTTR. It's going to allow us to do GET requests from R. I'm also going to load the imager, or image R right here, which essentially is going to allow us to look at and display images and also load them and potentially go get them from a different URL. And so each of these are separate libraries, just like we used scikit-image and requests that were part of Python. We're going to use these. So let's go in here, let's clear all of the outputs that we have right here so we can see, cell, all output. Let's clear all of it. So the first thing that we'll do is just load up these two libraries. And it's going to give you a little bit of feedback on what it's doing, on that it was loading a bunch of other dependency libraries for things. So I'll be able to load things like pings and JPEG and use them from R. So the first thing I'll do is tell it that we're going to be using the library HTTR. And I will go in and I'll use the scan function that's part of R to go in and load up all of the characters from this file, the New York Times API.txt, and that will load up my API key, just like we did from Python. So the URL that we're going to be going through is exactly this article search.json that we had before. And now, because I've loaded this HTTR library, I have access to the get function. And with the get function, I can use a get request, give it this URL, and then one of the parameters that it takes in, exactly like we had before with the request library in Python, is a list, which is essentially a dictionary with this key and this value pair, and this key and this value pair. Right? So I'll be able to use this query of saying, okay, here's my API key, search for anything with the query Olympics in it. And now I'll be able to say, okay, so that gets saved into R. So this is the response that we have from the server. And I'll say, okay, well, let's go get the content of R that we had before. And let's look at the response and docs. Exactly like we accessed a dictionary before in Python, we're going to be doing the exact same thing here, except it'll be content R, go into the response dictionary, into the documents dictionary, and save that into articles. And then we'll print out articles and see what this is. So if I run this, it's going to go out, grab all of that data, and now we can see articles is a huge list where it's got keywords like rank, is major, name, value. If we go down here, we'll actually see keywords like International Olympic Committee, document type. So it's got all of the same types of things. It's harder to read in this format, but it's got all of the same information that we were getting from that JSON object that we deserialized in Python. It's the exact same thing in articles. So let me grab articles at the 1 right here, and you'll notice that I've got these double braces right here, so we can actually access articles at the 1. And then I will access that list, that dictionary, at the lead paragraph. So if I were to access this and print it out, I'll see that, oh, this is the lead paragraph text that we got before. And all I'm doing here is going and grabbing the first article and the lead paragraph from that article. I can also just save, call this sum article is equal to article at the 1. And now sum article is a new variable, which is a dictionary, the R list, which is a named list, which is basically a dictionary. And I can grab that at the lead paragraph. So if I grab this, in the same way as we did before, I can paste together two strings where it's this URL, and I'm going to go in here to some article, at the multimedia, the very first element of the multimedia, what is the URL, right? So just like we did before in Python, we're going to go and there's an array of multimedia that might be associated with the article. And the first element inside of those multimedia objects is going to be a URL, right? Now, again, this is something we'll subsume away from the programmer. We'll write code to do this for us so that we don't have to remember this in whole format. But we're going to paste together those, and let me print out what the URL that it comes back with. It's this URL right here, right? So this is just a URL that has that that image inside of it. So if I were to go here, paste in, I actually already have it loaded. It would just, that is the image that's saved by the New York Times. So we can download that using the ImageR library. So it's a little bit more difficult to use ImageR with this because it's expecting everything to be loaded onto disk. So the first thing we'll actually have to do is download the file. And the way that I'm going to do that is by using this temp file property. And I'm going to say, okay, this is the image URL. Create a temporary file and write everything that you read from that URL into this file. And now I'll be able to actually load the image and I'll be able to plot it right here. So this is actually much more C-style syntax, but all this is really doing is downloading the image and then I'm going to plot it using the ImageR plotting library. And we can see I'm able to plot the whole thing right here. So it's very, very similar to Matplotlib in that respect. Okay, so that's just recreating what we had done before in Python, just kind of getting familiar with some of the syntax that we're going to use. Now let's go in here and actually create an object-oriented version of our article class and our article with media, and also our media classes that we created in Python. So the first thing we want to do is just create a generic article. So again, the way that we do this is through setClass. And so we're expecting now to have a class which takes as input the data, and it'll have keys that are part of the properties for this class. So the properties it'll have are the data that we actually are going to access and the keys for the data. And so because of that, we'll create the initialization method for article. And we'll create a function right here which takes as input the object and any data that we're going to save. And so now, because I've defined this data and keys properties, those are part of the object properties that I can set right here. So I'll say data is equal to data and keys are equal to the names of all of the data right there that we have. So data is a dictionary, so let me get all of the names that are in this, this data dictionary. And then I'll return the object. And that's just something we have to do as part of the S4 initialization protocol. Now we can actually create a generic function using these two things, which are setGeneric and setMethod. So we create a generic function right here, which has one parameter as the input, and the first input is always the class object. And then we'll actually define what that is. So right here it's some function. It's a standard generic. It's going to be called getParam. And now we actually define what that method looks like. So we'll say, okay, this is getParam for the signature article. And the definition of this function is as follows. We take as object and parameters, and then we say if parameter is in the keys, well, we're just going to return the object at that parameter, exactly like we did in Python. And again, this parameter, I have double curly braces into data right here, so that I actually return what's inside of object data at the param. If it wasn't in there, I'm just going to return an empty string, right? So we'll define that. Now we have this initialization and get param. So article, you'll notice I saved it as the set class, right? So now I can use it as the initializer. I can say, okay, well, A is equal to, let's create an article from some article. This is some article right here. Some article was text that we had, or sorry, it was a dictionary that we had defined up here, right? Where some article, here, we defined it here. It's the very first article in the list, right? So we're going to use that as the dictionary element, and we'll save it into A. Now I'm going to call getParam, the lead paragraph from A, and hopefully it'll print out the lead paragraph that was part of this article. So now we've got our own object-oriented way of getting the parameters from that. But remember, we defined a recursion in Python to where we could provide a list of the hierarchy of parameters that we wanted to transverse through. And then we could actually just traverse them and return any of the elements that were in part of, so we can access a dictionary within a dictionary within a dictionary if we wanted to, and grab access to all of the certain properties that are part of the New York Times articles that we had. So let's create a new function called getParamRecurse. And the only thing that it takes is a list. Okay, so it's expecting a list. So this is kind of an interesting way of doing this, but I'm going to set that generic and then set this method. So get parameter recursively for article. And I'm going to define the function here where I give it a list of parameters that I want. And now, exactly as we did before, this recursion should look very, very similar. When we first call this recursion, I'm just going to call recursion underscore, and I'm going to give it all of the dictionary data for our object and the parameters that we want to traverse. And what that's going to do is it's going to call this recursion underscore function. And again, I've defined this recursion underscore function inside of another function. So its only scope, recursion underscore, it's a private function, and it only works inside of our getParamRecurse function. And that's very, very similar to Python syntax, except now we're doing it from R. So this function takes as input data and then a list of the parameters that we're going to give. So exactly as we did before, what I'm going to check is, are there greater than 0 parameters inside of this rparam list? And is the first element in that list part of the names of the data dictionary that I have right here? If it is, I'm just going to call the recursion again, and then I'll pass whatever dictionary it's pointed to, and I'll pass the remaining parameters, right? So I'm accessing this dictionary, I'm sending whatever dictionary I'm pointing to, or it could be data, and then whatever's left in the list from 2 to the length. However, if that data was a character, I'm just going to return the data right there. That means we've gone to the end of the dictionary. That's as far as we can go. I'm just going to return it. If there's only one parameter left right here, then I'm actually going to call a recursion right here. We'll say, okay, if the length of the parameters in the list is only equal to 1, I might as well just return the data at that parameter right there. And if it doesn't exist, I'll return an empty string right here. So this is almost identical to the recursion that we did in Python, just eats through going and creating a smaller and smaller list as we access further and further down into the nested dictionaries that are part of this article. So let me define this. Great, we've defined getParamRecurse. So now we should be able to go into this article A that we've defined before and say, okay, well, we want to access headline and then main. Let's do it. We can access the text that is part of the dictionary that's part of headline, and then it goes into the dictionary main, and it grabs the value associated with that. Okay. So now we can define our summary function exactly as we did before in Python, where we'll create an article summary function and set it equal to, so we'll set that equal to a generic, and then it's part of the article class. And then we define it. We say, okay, for element in the list of everything that we had before, where we have a list where we want to go to headline main, we want to grab the news desk, we want to grab snippet, lead, paragraph, and abstract. And we're just going to print out getParamRecurse for the object that we have and this element right here, which could be a list, right? And so once we've done that, so we'll define this method. All right, now article summary is defined. Well, now for every article, for A in articles, our syntax, we're going to print a summary, right? So what we'll do is we will create an article A from it, and then we will print out an article summary by passing in each of those articles that we've now encapsulated inside this S4 class. And so if we do that, voila. We've actually got a summary very similar to what we did in Python of all of the headlines, the subsections, what news desk it went to, and then also whether or not there was a snippet, the lead paragraph, and an abstract for each of those articles. Okay? So now we've gotten all of the functionality for the article class that we wrote in Python. We just have to go the next step and add multimedia to it. So it's pretty easy to do that. So before we had seen how we could download an image, and just save it, save the image data. So the way that we're going to do this is we're going to create this New York Media class right here, New York Media, and it's going to have parameters, objects, which are media and image right here. And image is going to be of type C image. That's what's basically used under the hood of the image R library, right? So we're creating a new class, New York Media, and then we're going to look at the initialization function for New York Media. So inside of this, it's expecting us to send in the media data, which is just going to be really the dictionary of all of the media elements. And the only thing that we really care about is the image URL from that. So if we go to our media, let's say object at the media, let's grab the URL to this media, paste it onto the NewYorkTimes.com, and save it inside of img_URL. Then let's attempt to download it and save the image data into this property image, which we had set up here, which is of type C image. So we're going to save the image into there and then remove the temporary file. And all of this code is exactly what we did before when we downloaded the image and showed it. Right? I'm just not doing the .show command. Right? So we'll return then the object because we're at the end of the initialization function, and hopefully once we create this New York Media article, it will immediately download and save the image that's saved inside of image URL. So now when we want to define a getImage function, it's as simple as going in here and only returning, let's say, so the method we'll have here is getImage associated with New York Media. And the only thing that it's going to do is just return object at the image. So we'll define those. And now we can say, okay, for each of the pieces of media inside of some article of the multimedia. So for each piece of multimedia, let's just create media equals nymedia. And then we will plot the value of what happens when we call getImage on that media object. So let's do this. And if you'll remember, there were three different images associated with that. And if we look at them, here they are. So we have the first image, the second image, and the thumbnail image. And they're all of the same size as we saw before, the same type of thing that used matplotlib. Image R will kind of default everything to be about the same size. So great, so we have that nymedia object. So what we'd really like to do is create a list of all of those nymedia objects and save it into a new class, which is an article with media. And exactly as we did before in Python. So with this, we're also going to set up some inheritance. We're going to set class, it's article with media. We're going to create, okay, it's going to have data, keys, and media as part of the properties that are part of this. And it's going to be a subclass of the article class, right? So article is its superclass. So now all that means is that when we define the initializer for article with media, we're going to go in and we're going to say, okay, does media exist in this data at all? Because data is passed in, right? So we'll get length, the length of the multimedia part of this dictionary. If n is greater than 0, right? So if it has a length greater than 0, then we're going to go through and we're going to create a vector right here. So this is a vector of length, however many elements are part of multimedia. And then for each element inside that vector, it's going to be equal to a New York Media object of data at the multimedia right here, right? So exactly, it's just a list of objects exactly like we did in Python before, right? Where object at the media at the I is equal to, it's initialized to class nymedia, right? So immediately when I tell it the multimedia object, it's going to go download the image and save it into this media at the I at the image property for that. All right, so I'll just run this and then actually create article with media equal to some article right here. And so now once I've created this, it's already downloaded all of the images that are part of A. So if we wanted to show those images, we can just add a generic function called show images. We're going to add it to the article with media class. And then we're going to go in here and we're going to use the plotting library that's part of R. And so, you know, the way that we can do this is each object is going to have a certain number of images. So we'll display each of those images inside of a single plot. And so I'm going to define the layout right here, which means I've got a from 1 to the length of media, right? So potentially it's kind of like the way that subplot works. How many plots are you going to have that are part of one giant figure? In this one, I'm going to give it a list from 1 to the length of media. Typically, this is going to be 1 to 3. So it'll create 3 different subplots inside of the figure. And since I'm passing in the object here, I can again call getParams recurse on the object and grab the main headline from this object, right? Because it inherited from article, so I can absolutely call this on the function, on the class. I'll save that as the title, exactly like we did in Python. Now, I'm going to say, okay, for I in sequence along the object at media, right? So for each object, this is basically, it's kind of like an enumerate, right? Where I say, for I, which is an index, it's some integer in this sequence along it, I'm going to plot it right here. So if I is equal to 2, I'm going to get the image, object immediate the I, and I'm going to plot it, but the title I'm going to set as whatever we set the string title to be here before. So this is actually some pretty interesting syntax, but this is how the plotting library works for this. You know, if we're not trying to set the title, we can actually just call, oh, okay, we'll get image, and we pass in the media object that's there, and then we plot it right here, and that's fine, and it plots it into whatever element we're going through on the layout. Otherwise, we can plot it right here with this title using this as input right here. So this is kind of a keyword for input into the plot function with this title set. Right? So if you've never seen this syntax before, this is very classic R. There's lots of ways of doing different things, and they're not necessarily intuitive. It's just something you have to memorize and get used to. If you're going to use R, that's what you need to be concerned with. So with this, what we'll do is I will just create article with media A, and I'll call show images on A right here. So if we run this, we've called show images on A, and it's done exactly what we really wanted it to do, which was go in, plot 3 different subplots inside of one figure, and it gave a title to the middle figure, right, which is I equal to 2, and then displayed it inside of our notebook, right? So again, this would be something to where we actually want to go in here, and we probably want to redefine this show images function to try and well, not be so, we need to set the image size exactly like we did in Python. And so the only thing that I'm going to set up differently here is I'm going to set this layout right here to be widths, the widths of each of the media objects. I'm going to set it to be 2, 4, and 1. So I'm just going to hard code it here, where I'm going to say the middle image should be twice as large as the smaller version of it, which should be twice as large as the thumbnail. Right? So I'm going to kind of specify what the widths are inside of this layout function that we had. Right? And then everything else stays exactly the same. Right? Exactly kind of like we did in Python, where we used the grid spec function, except here we're telling the widths explicitly to be 2, 4, and 1. If we wanted to, we could make this a lot smarter and say that this should be equal to the number of rows for each of the media items that we have. Right? But we'll just define this here. And then we'll call show images. And this is a little bit, it's not quite as smart as the matplotlib function right here, because it's kind of compressing everything down, but it leaves the columns exactly as they, all of them the same length. So really what we'd like to do here is go in and define also the column and the row height for each of these plots. However, I'm going to leave that as an exercise for you. So before I leave you here, let's do one more thing. So using this article with media, it's a very expressive syntax. I can create this articles vector, which is a list of length articles that we have right here. And articles is something that we created before when we just grabbed all of the articles that were part of the docs response from our HTTP response. So this articles vector, I can say for I from 1 to the length of articles, create this articles vector, articles with media, and then I'm going to give it the information for articles at the I. So grab that dictionary, create an article with media object, and save it here. And now for each of the articles in this articles vector, call show images on A right here, and now this should go through every piece of New York Times article that we have, download all the images, and display them appropriately. And this is exactly what we're seeing, and it'll give the title that we have right here. So this is exactly the same thing before as we'd seen with Python, except now using the whole thing in R. So if you want to check to make sure your understanding of this is correct, one of the things that you can do here is, let's make these actually better images to where the columns, we actually tell it the rows and columns that are in each of the images. And so I've given you some starter code to figure that out. But essentially, you're going to want to look at some of the advanced ways that you can use the layout method that's part of R. And I've given you some starter code to figure out, okay, well, here are the widths and the heights for each of the media objects, each of the get image images that are part of the object media class that we have. So this code will be able to tell you what the widths and heights are, and it'll save it into a vector. And now you should be able to use that inside, without too much manipulation of the code, to use this advanced layout option and really check your understanding if you're working things correctly in R. So I'll leave that to you, and thank you very much for your attention.